This is a demonstration of Port Power's system working at Family Laundry's Oakland EV charging site. What you're seeing is the real-time site view. And in this view, we'll literally see what's happening in the site every given second. We have a total of 17 parking spots at the site. 15 of them are equipped with AC level 2 chargers. A couple of them are equipped with DC chargers. We see that 4 vehicles are being charged now, and those are family laundry vans. We know that because the system identifies them. I'll click one of them, and you will see that the vehicle is charging at the parking spots. We have a small camera attached to each one of the chargers that monitors the parking spot and monitors the charger. The information about the vehicle is here, and obviously information about the charging session. The system has a vehicle management capability, so the EV fleet is updated in the system. In case of fleets that have telematics, we connect to the telematics system. That's how we know the vehicle state of charge in real time, and it allows us to prioritize vehicles for charging based on when they need to leave and their existing state of charge. As you can see here, 3 of the vehicles are being charged right now. I'll go to the charging screen. The system automatically decides at what speed to charge each vehicle based on their priorities. The system can prioritize particular vehicles for charging, so charge them faster or charge them before other vehicles based on which fleets they belong to, or even based on manual action. So the fleet manager can say, this vehicle is lower priority or higher priority, charge it faster. Port Power's approach to running power and energy at the site is to look at each site as a microgrid. The site has power available from a number of sources, utility, but maybe also solar and battery, even generators. The power serves loads, the EV chargers, but also potentially building and industrial loads. The system job is to automatically take the power available and use it optimally in order to make sure the vehicles do their missions, in order to reduce the cost of energy to the owners, and in order to meet resilience goals. So at Family Laundry, the system doesn't only manage the chargers, it also manages the grid connection, 50 kilowatts of solar, and 233 kilowatt hours of battery storage. All of that means that the system is planning energy, and what we're seeing here are 2 things: how the system used energy over the last 24 hours. We see which vehicles were charged at every point in time and where the energy came from. And we can even see the system planning energy forward, making assumptions with regards to where the energy will come from, or the power will come from, and how it will be used to charge vehicles. So the system thinks forward and can tell the fleet manager if it thinks that it will not have enough power to charge a fleet in the next 12 or 24 hours, and some vehicles need to be sent somewhere else. So to recap, full site management with site monitoring with cameras, license plate recognition, and telematics-based recognition of vehicles. Vehicle and driver management, so you know who's charging where, you know what the priorities are, and you can even contact the drivers if you need a vehicle moved. Charging management that is fully intelligent. It takes into account all of the resources and splits them to the right vehicle at the right time based on the needs of the fleet and the vehicles. All of that happening in a microgrid that also recognizes the sources for power and potentially who else might be using power, the building and so on. Energy planning, energy optimization, and reports that allow you to provide data for billing, data for the utility, data for authorities, and so on and so forth. That's the Port Power system working on Family's Laundry EV site in Oakland, California.